Hi everyone, this is the gas walkthrough for January 4th. I'm Philip Newman. Today I'm solving Throwdown by Bill Murphy. This is an XV Sudoku. I did not say XV pairs. This is an XV Sudoku with a negative constraint. So we have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have some clues in the grid. And if two cells are separated by an X, they sum to 10. And if they're separated by a D, they sum to 5. And if they're not separated by anything, they don't sum to 5 or 10. Otherwise, they would have a letter. So these two cells cannot sum to 5 or 10. This applies to orthogonally adjacent cells, cells that share an edge. It doesn't apply to diagonals. I don't know if anybody's done a diagonal XV, actually. Anyway, not relevant for this one. So those are the rules. And let's get started with the clues that we do have. This is a V, it sums to 5, and there's a 3 in the box, so it can't be 2, 3, it must be 1, 4, and we know the order. And that's going to give us the X's. These sum to 10. We're going to do the same thing here. Can't be 1, 4, can't be 3 in this cell. Here, can't be 2, 3, and in fact we have all the other digits here. So it goes like that. And then here we need the 3 there because of these. And that is all the clues. So now we're going to do some combination of regular Sudoku and the negative constraint. So we'll be on the lookout for where we can use that. And we will start here. Bill has designed this so that in addition to resolving these clues, the triples on the outside of the grid are also going to tell us something because of the negative constraint. 2 can't go next to an 8 unless there's an X, so this must be 7. Over here, these are 1, 6, and 9. We have 6, 9 there, so that's 1, and 8 can't go next to 9. Here we have 3, 7, and 8. I'm going to say this a little different. We could place the 3 just like we placed the 1 and the 2. But also, can this be 3 or 7? The answer is no, because then either this would be 3, 7 or this would be 3, 7. The 8 has to go between them to keep them separated. So that is that, resolved by that 7. And then these are 4, 6, 9. 4 can't go next to 6. Alright, that's the corner boxes done. Let's look at the edges, figure out what else we need here. 3 and 6, 4 and 8, that is resolved. 2, 9 here, and 1, 7 is resolved. Okay, here we have 5, 6, and 7. This can't be 7 for multiple reasons. This can't be 6 because of 4. Actually, 3 reasons that couldn't be 7. These are 1, 2, 9. 1 and 9 can't go next to each other, so the 2 has to go in the middle. And there's 1 over there. Alright, these are 5, 6, 8. And this can't be 6 or 8, because of that 8. These are 1, 3, and 7. 3 and 7 again can't go next to each other, and we have 1, 7 here. Alright, these are 5, 8, and 9. That's not 8 because of the 2's. That's not 9 because of the 1. That's not 8 because of this 8, so that is our 8. And then these are 3, 4, and 6. 4 and 6 can't go next to each other, and that can't be 4. Alright, up here, 5, 7, 9. This can't be 7, and it can't be 9 next to the 1. And actually, we have a 7 here as well. These are 2, 4, and 8. The 2 and 8 can't go next to each other. And we do have an 8 here. It's going to resolve our 6, 8. Alright, I don't see anything else. Yeah, I do. There's a 7 there, so that can't be 3, that must be 6. and the 8 here. Symmetric deduction. I feel like I checked these and just didn't check over here. The symmetry is a little different in this puzzle. There is some symmetry, but it breaks in interesting ways. Alright, 5, 6, 9, this is 5, this is not, oh, that's not right. 5, 6, and 2. This is 2 then, and this is going to be 6. This is the 5 here. That resolves 7, 6. This is now a 1. This is 3 and 5, which we can do. It's going to give us 5 and 9, and finish 4 and 9. And that's the solution. About as gentle an introduction to a negative constraint as you can get. Puzzles with negative constraints are notorious for the possibility of being very difficult. And they're hard to set. A lot of setters use tools that show remaining candidates, possible solutions. Negative constraints mess with that in that not having a clue in one place versus having a clue has an effect on the entire grid, potentially. So it can be very hard to make them work, especially nice and symmetric like this. This is a totally symmetric puzzle. It's just not fourfold symmetry. So 1 and 4, 3 and 2, 7 and 8, and the 5s are symmetric with each other, and then 6 and 9 as well. I knew I had messed up immediately here when I put a 5, because I knew it had to go there. Anyway, I hope you found that interesting and enjoyed it. Let us know how you did in the comments, and I will see you next time.